All right, guys, here we go. Let's talk about poly assignment number 8. Again, we're just kind of redoing these things and kind of showing you different ways to deal with it. So we're going to talk about the remainder theorem on this one. So that'll be in the sections 4.6 through 4.8, 4.6 through 4.8, I believe, or 4.7 in there somewhere. So basically the idea is this on the first couple of this one for polynomial aids, guys. Number one, use Desmos. So if you graph it, if you graph those on Desmos, if you graph this one on Desmos, you're going to get something that looks like this. So we're going to get one at 3, one at 1, and one at -1. If you use Desmos, that's where it would be. And so to prove that these are zeros, you would either factor them and show them. So I do factor by grouping. I can take out an x squared out of both of these because I'm going to make this one here my blue group. I'm going to make this one here my red group. Don't forget there's an imaginary -1 right there. So if I factor out a -1 here, I get x minus 3. If I factor out an x squared, I get x minus 3. Don't forget when we're factoring, with the greatest common factor, we're just dividing by x squared. So that's why x cubed divided by x squared is x. X squared divided by x squared is 1. That's why the 3 is left. So don't forget, that's how we factor. Just a reminder real quick, guys. And then once we do that, the two greatest common factors become one factor. Blue and red become purple. And then we set them equal to 0. And if we solve that, we get the square root of both sides. And we get plus or minus 1, which proves that that's algebraically, it proves what it looks like on the graph. And then we have x minus 3 equals 0. And then we have x equals 3, and 3 is right there on the graph. So we prove that. So let's just hypothetically say that, I won't even say hypothetically. Another way to prove that they're zeros, especially when it's not factorable, is to use synthetic division. So if I go and look at this, and let's say 3 is my answer. That means x equals 3, right? X equals 3. So if x equals 3, we set up our division here. X equals 3, and then I take my coefficients, 1, -3, -1, +3, and then I bring this one straight down. 1 times 3 is 3. Add the columns together, I get 0. 0 times 3 is 0. Add the column down, I get -1. -1 times -3 is -3. And here's the big one. It's 0. So, since the remainder equals 0, then x equals 3 is a x-intercept. So, a couple of ways to prove that they're zeros. Number one, factor them and find the answers that match the graph. Or use synthetic division for the zeros that pop up on the graph, and then once you get a remainder of 0, you have proven that it's an x-intercept because x equals 3 has a 0 remainder. So no remainder means it is an x-intercept. So now, the final piece of this puzzle, guys, let's look through, make sure this thing's still recording because it was running low on battery. Okay, a little bit longer. So that's 1 through 3 for this one, guys. Don't forget on number 4, on B, you need to adjust the range. We give you directions on how to do that. And that's another remainder theorem problem on 4. 5, 6, 7, and 8 are all, and 9 are all reviews. Don't forget on number 5, you list them all out, and we're looking for groups of 2 because it's a square root. Number 6, For number 6, guys, don't forget that I squared is equal to negative 1. And then that I is equal to the square root of a negative 1. So that's for number 6. Don't forget that, guys. Number 7, don't forget to set it equal to 0. Number 8, just construct your basic confidence interval. And number 9, don't forget about the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You can look that one up. Other than that, that covers a polynomial assignment number 8. We'll see you guys soon.